What you see here is my Macintosh desktop, or at least one of the screens, nicely cluttered up with all kinds of things that I am currently in the process of doing. But what I'd like to draw your attention to is this Windows 10 screen that you see here. What I've done, I've installed a product called Parallels Desktop. And what it's done is it allows me to run an entire Windows PC inside a Macintosh window. I wanted you to see that so that those of you who are using Macs know that this here option is available to you. I've included a few other options in the syllabus and in Canvas. But at any rate, let's go ahead and we'll zoom into all of this and we'll begin working on some assignments. Okay, before I get started, I'd like to say please forgive me. I have a really nasty cold and I'm having difficulty talking right now. But what I wanted to discuss was how are we going to handle managing our files in this particular course. If we're going to write a program, it probably would be a really good idea to have a place to store those programs. Moreover, it would be very, very beneficial if we keep those files nicely organized. So what I'm going to do is I'm going to get into my File Explorer so that I can create a place for these files. So I'll go into this PC, local disk C, or whatever disk you want to use. I'll right click, new folder, and I'm going to call it IS_115. I tend to use underscore for spaces because then it's easier to see the spaces. I will double click in there and I'm going to create another folder to hold this particular example project. And following my naming convention, I'll use my last name with an underscore and then my first name with an underscore. And since I'm really not doing an actual assignment that we have in this class, I'll call this example. At this time, you could probably, if you wanted to, you could continue creating folders. You could say Broderson, or in your case, your last name, your first name, and then say A1 to hold all of your A1 assignment files. Broderson underscore David underscore A2 to store those files. So hopefully that'll get you on the road to creating the structure of directories that you need. Once you've created or completed an assignment, then all you have to do is right-click one of these folders and compress it down into a zip file and upload it into Canvas. Okay, if we're going to put something into a computer, I guess we need to begin with a problem. And in our example, what we want to do is we want to have a look at a square, okay? And I want to, we'll go ahead and put in length up here, in width over here, so that we know what we're talking about. I want to have the user input the length and the width, and then the computer will report back the area and its perimeter. So the area of a rectangle is going to be equal to the length times, and I'll use a little dot for times, the width, and the perimeter is going to be equal to, let's see, we have a length there and we have a length there, so there are two lengths, and we have a width there and a width there, so there are two widths, so it's going to be 2 times the length plus the width. Make sense? So we've defined our problem. So the next step then is to craft our pseudocode. So the next step after we've defined our problem, which is given the length and the width of a rectangle, report the area and perimeter of that rectangle. Okay. What we want to do is we can either flowchart it right now or we can write it as pseudocode. Now I know a lot of people just simply go straight to the pseudocode and then do the flowcharting next. It's kind of up to you, all right? So what exactly is pseudocode? Well, pseudocode is a detailed yet readable description of what a computer program or algorithm must do. An algorithm is nothing more than simply the steps that a program must take to complete or solve a problem, okay? It is generally expressed in a formally styled natural language rather than in a programming language. Thus, pseudocode is kind of universal across all of the disciplines or all of the different ways in which we code computers. Pseudocode is sometimes used as a detailed step in the process of developing a program. It allows the designers or lead programmers to express the design in great detail and provides programmers a detailed template or structure for the next step of writing code in a specific programming language. Because pseudocode is detailed and yet readable, it can be inspected by a team of designers and programmers as a way to ensure that the actual programming will probably match the design, or rather that they will in fact match the design specifications and probably work. It also helps us to catch a few errors before we actually get inside the computer and begin to write our program. So, one of the rules that we do in this class with respect to our pseudocode is we divide things out into 3 different stages. All computers require input. They all will do some kind of processing. And once the processing is complete, they are going to provide output. Okay? So let's write the pseudocode for getting our input. Well, we want to go ahead and say let L, that's for the length, equals user input for L. Okay? And let W equal user input for W. Suddenly occurs to me that you might want to prompt the user for the length, right? So we might want to say prompt user for length. And down here we might say prompt user for. Now some pseudocode actually provides a little more detail. For example, instead of just simply stating prompt user for input or for length, you could say print enter, enter the length. And then down here, let me just copy this. Enter the width. Now what's going to happen in a real program is if I don't give it some kind of a space, whatever the user types, it'll be jammed right up against the prompt, and we don't want that. So we'll go ahead and put in a little bit of space to make life a little better when it comes to the user experience. Now that we have the length and the width, it's time to do the processing. And the processing is basically going to be set the area equal to the length. The asterisk is used for times in a computer, so the length times the width. And then we want to go ahead and set the perimeter equal to, and some folks, what they're going to do is they'll go 2 times, and you'll notice, by the way, that I'm putting a space between the operator and the actual variable, okay? So I have 2 space and times. It isn't required, but it sure is more readable, all right? I'm going to do parentheses. Now, some folks, they like to put in a space and then the length, or the variable name, space plus the operator, put in a space and the width, while others prefer that the length and the width are jammed right up against the parentheses. I've seen excellent arguments for both. I don't personally care, but you do need to make sure that it's consistent. All right? So now we've completed the processing section. So we're ready to go to the output section of our pseudocode. Okay? And the output is going to be print the area is colon, and then we add a line that says print A, and then down here we'll say print the perimeter is perimeter. The perimeter is colon, and then we come back here and we do print p. And that is all of the pseudocode.